Hi there, dear students. We are back again to keep studying and explaining Chapter 5, Section 2. In the previous section that we have studied the characteristic of light and the formula of frequency and wavelength, and even we have solved the example. So now we have a new section, Chapter 5, Section 2. The name of this topic in here it's written flat mirror and reflection of light. The first step for now, we are going to study what is the meaning of reflection of light, or what is reflection in general. Uh, reflection in general, reflection in general. First of all, we have to know what is the meaning of reflection. Reflection it means the change in direction of an electromagnetic wave at a surface that it moves away from the surface. Uh, Look at here, guys, students. For example, you have this surface. This is a surface, any surface. And for example, if you are take one of the light that it comes in that direction and it hits the surface. For example, I'm going to take this light. For example, let me say that this light came out from any of the source. For example, sun. This is the light or electromagnetic wave. This is not important. Yani, for example, this which type of electromagnetic wave? Is it gamma ray? Is it X-ray? This is not important. We are talking in general. This is light. When this light it came, and this light it came and to strike and to hit this surface. The light it came in that direction and hit this surface. After that, what do you think is happening then? This light it's going to be reflect in that direction, in the opposite direction. So first of all, the light came in that direction, then hitting this surface going to be reflect in that direction. So this is called reflection in light. Reflection, what the definition said? The change in direction of electromagnetic wave. Of course, look the direction it changes in here. First of all, the light came in that direction. After when it hits the surface, it goes and keep moving in that direction. It reflects in that direction. So first of all, the direction it was like that, and look, the direction it changed now. So the changes in direction of the electromagnetic wave. First of all, the direction it comes toward to the surface. After that, it keeps away from the surface. The direction of the light it reflected and keeps away from this surface. Look, that goes to move away from the surface. So this is called reflection in general. In general, understand when any of the light that you have it hit this surface, it's going to be reflected. This is called reflection. The light's directions like that after it hit this surface going to be reflect. So the direction of reflecting light it keep away from the surface. Or for example, this mirror, for example, you are staying in here. You can see your picture. Later we will explain how image is going to be create and form. So this reflection in general. That was reflection. So we have now two type of reflection. The first called this is called smooth. This is called smooth surface, or we have two type of reflection. That one is called specular reflection. Specular reflection. This is the second type of reflection, which is called diffuse reflection. Diffuse reflection. Diffuse reflection. So there are two types of reflection. This is called specular reflection. That one's called diffuse reflection. How we can make a difference between of them? Good question. If you notice that in here, the surface of this type, it's smooth, it's straight line, it's smooth. When the light it came in that direction, if you notice that when the light it came in that direction, and it reflects in the same direction, light regularly, the lights came arranged, and even though it reflected with the same line without like the direction it came that direction, without being like deformed, something like that. Look, the direction of incoming light, this is incoming light, and the light is going to be reflected. So let me write down the difference between them in here is better. The first fault that you have, this is called diffuse reflection, but that one, sorry, this is specular. This is specular. The surface of the specular, so the surface of this diffuse, it is like rough surface. It's like a rough. This is the surface of the diffuse, and that one specular reflection, and the surface smooth. So when in diffuse surface, the light is came in that direction, and it's going to be reflected in the other. When incoming light strike this rough surface, like a paper or clothes or anything, become. For example, this paper surface is not smooth; it's rough. So the first property occurs when light strike the rough surface. Look, the surface is rough, not smooth. It's like that. Look, when the light came in that direction, it strike or hit the rough surface. Second property of the diffuse, the normal are not parallel. Second property said reflected light are reflected in many direction. Okay. When the light is struck and the light it came and passed to the surface in that direction, it hit the surface. After that, going to be reflected maybe in that direction, or for example in that direction, or for example in that direction, or in that direction. Or because why? Because the surface is rough, and when the light is came that direction, this is the incoming light. The reflected light, we don't know are going to reflect in which direction, because this is randomly, maybe in the up or to the right side or in that direction. It's randomly. So that's why in it is written are reflected in many direction, because the surface is rough. Maybe it goes in the up or right on that direction. So randomly they are reflected in many direction. So because the surface is rough, the reflection, the third one, the reflection is irregular. irregular. Not arranged, of course, not arranged. Because are reflected in many direction, and of course the reflected ray, the reflected light going to be not arranged, irregular. The fourth rule said it cannot determine it cannot determine the direction of the ray. The direction of the ray of the rays. We cannot determine easily the direction of the ray because all of the reason that in here we have said the reflected light is not irregular, or the reflected light are reflected in many direction, or we cannot determine the direction of the ray. All of the result because the surface is rough. Reflected light are reflected in many direction, of course, because the surface is rough. The reflection is irregular because look, because in here we have rough surface, they are reflected in random direction, so it's irregular. It cannot determine the direction of the ray. We cannot determine easily because it's difficult or complicated the direction. Okay. The last property, the last one, the last property. It cannot. Sorry, the normal are not parallel. Also, the normal are not parallel. The normal are not parallel. Are not parallel. Also, reflected ray. Also, reflected rays. The normal are not parallel. So first of all, you have to know what is the meaning of normal are not parallel. The normal are not parallel. The normal are not parallel. For example, let me draw again another picture. This is the rough surface. In here, because the surface is rough, the normal line is like that. One of them we have this dot line. One of them is for the left, the other to the right, the other to the up. Look, even though we have a normal line, these normal line are not the same direction, not parallel, because the rough surface. But if we have a smooth surface, the direction of the normal line is straightward, like it's straight without being left or right. It's straight line we have. Both of them, all of them to the up, like that. We have this dot line. This is the dot line of the surface. If we take each of the point to the surface, they have this dot line. The directions to the up. For example, this point of the surface direction to the up. This point to the surface, the direction to the up. This point to the surface, direction to the up. This is the same thing, the direction to the up. Because the surface is smooth and straight, the direction of the normal dot line still it's straight and regular to the up. Look, but in here, because we have a rough surface, this is to the left, this is to the right randomly. So this is about diffuse. Now, if we take the smooth surface, the first property, when the incoming light strike the smooth shiny, look, the incoming light are strikes smooth surface. Smooth surface. We know this when the incoming light hits the smooth surface. When the light came in that direction and it hits this smooth surface. The second property, the normal are parallel. Only I'm going to mention this later, not now. At the last point, it can determine or reflected light. Reflected light are reflected in the same direction. Are reflected in the same direction. Reflected light are reflected in the same direction. How? When this light it came to pass to strike this surface, the reflecting light going to be reflected in that direction, regular direction, not like the rough, in random direction. So the light are reflecting by the same direction. For example, this light is reflecting in that direction. This is the same thing, All of them, they are reflecting in the same direction. The reflecting light, they have same direction in that direction. But the rough, it wasn't like that, Maybe one of the lines goes to the up, the other to the right, or the other to the down. So, and that's on, because the surface is rough. The third property, the reflection is regular, of course. The reflection line, all of them regular. It's clear. Regular reflection. Regular reflection. Regular. Regular reflection. It can determine the direction of the wave. It can determine the direction. It can determine the direction of the rays. How we can determine the direction of the ray? Because if you see by your eyes, we can't separate all of them, because all of the direction of reflection are regular, regular, not mixing like this one. So in here we can easily determine and measure the direction of the reflected ray. One thing that's left, the normal are parallel, and also the normal are parallel. The normal are parallel. I told you what is the meaning of this. When we have this smooth surface, when these lines came and hit this surface in that direction, because the smooth surface, the reflect light going to reflect in that direction. And as I told you, each of the point of the surface, each of the points, it has a normal line and the direction to the up, direction, all of them to the up. Why all of them to the up, and why all of them the same direction to the up? If you notice the direction of all of them to the up, yani all of them are parallel. You know why? Because again the surface is smooth, and the direction of the dot, each of the point in the surface, all of them to the up. This is in general the difference between diffuse and specular reflection. Important. That's why I wrote for you all of them. You can take screenshots, because it's important to know. Good. We have done to make a difference between all of them. So this is in general diffuse reflection. This is diffuse, the direction of the reflect in many direction, not regular, but that one regular. And that's it. Now we have another topic, which is called law of reflection. Law of reflection states that the angle of the incoming light are reflected ray are equal. How? Look, Baba. I'm going to explain on this picture. For example, we have this smooth surface. The surface must be smooth, and this is the incoming light. This is the incoming light. The incoming light, it came in that direction. This is the incoming light. We know that when the light it came and it hit this surface, after that, what's going to be happen? You know, the light's going to be reflect. So this is the incoming light, and this is the reflecting light. And we know, I told you, if you are taking this point, each of the point of the surface, they have a normal line. So because the surface is smooth, I'm going to take the point in here, the direction of a normal line to the up straight line, like that, straight line, because the surface is smooth, and the direction of the red line, it's regular. This direction. Okay. In here, if you notice that we have two angles. The first angle is called angle of the first angle in here that we have the name. Let me tell the name. Angle of incidence. Look, this is called angle of incidence. This angle, this theta, this is called angle of incidence of the angle of light. When the light, incoming light, came in that direction, it hit this surface. This is the incoming light and this is the normal line. Between of them there is an angle. This angle called angle of incidence. After, when the light going to be reflected, same thing is right. The angle between of the light reflected and the normal, in here we have angle of reflection, and the symbol is theta dash, or this small line. So this angle of reflection, this angle of incidence, the angle between normal and incoming light, and the angle between reflected light and the normal line. So in here we have law of reflection. Law of reflection, it said the angle of the incoming light, yani this angle, are reflected, the angle of incoming light and reflected ray are equal, and the angle of both of them are equal. This is the law of reflection. When this light, incoming light, it came and hit this surface, according to the normal line we have this angle, right? And after, when the light is going to be reflected, again according to this normal line, the angle between reflected light and the normal light, this angle is called reflected angle. So both of the angle are equal according to the rule, law of reflection. Law of reflection said both of the angle are equal, and that's it. Same thing, the law of reflection, we state that the angle of the incoming and reflected ray are equal. Incoming and reflected light are equal. Even you can see this when the light, it passes through this mirror. This is the mirror in that direction. In that direction, we see that the light is going to be reflected in another direction. Why the direction of the light is going to be reflected? It's straight line regularly, because we have mirror, and mirror surface, it's smooth, not rough. This is the surface of the mirror, and it's going to be reflected in that direction. So this is the dot line. So this angle, the angle of incidence, and this angle, the angle of this is the angle of reflection, and that one the angle of incidence. This is the angle of reflection, this is the angle of incidence, and both of the angle are equal according to the law of law of reflection. So every year I'm going to bring example of my students like that. I'm gonna write like that in exam. For example, I'll say the angle of incoming light. If the angle of incoming light, which is equal to 35, by what angle the light going to be reflected? So if you can take a look in here. Just let me erase it. This won't be erased. Wait a minute, please. Let me do it in here. Look, for example, when you have this surface, and this is the direction of the light, it came and struck this surface. This is a smooth surface, and because it's smooth surface, the direction of the normal line to the up in that direction, and with the light, it's reflected in that direction. So this is the angle of reflection, and this is the angle of incidence, and this is the angle of reflection. If the question said, if the angle of incoming light, which is equal to 35 degrees, by what angle the light going to be reflected? Yeah, find this angle of reflection. Still, it's 35, because we said according to the law of reflection, both of the angles, they have same value. So be careful. If by 35 degree we have the angle of incidence, by the same value the light going to be reflected. Good. So angle of incidence, the angle, same thing, the angle the angle between the incidence ray and the line perpendicular to that surface. The angle between the incidence ray, the angle between the incidence ray, it means this one. This is called incidence ray or incidence light. And the angle between incidence ray and the line perpendicular to that surface. If you notice that these dot lines are perpendicular to the surface, there is 90 degrees, right? So the angle between incidence ray with this dot line, this angle is called angle of incidence, or the angle between reflected ray with this normal line, this is called angle of reflection. Same thing, The angle formed between the reflected ray, as I told you, and the normal line is called angle of reflection. And we can say like that, the first angle of light, angle of incoming light, equal to angle of reflected. In here now we are going to study another part in here that it is called flat mirror. Flat mirror. What is the meaning of flat mirror? Just wait a minute. So students, now we are going to explain what is flat mirror in physics. So this is the flat mirror, this is the mirror, and this object is staying in front of the mirror. So we have a nice question actually in here. What are the property of the image given in flat mirror of an object that is placed? For example, the question said, when we are putting one of the picture in front of the mirror, for example, this object, this person, he's staying in front of the mirror, image going to be formed on the flat mirror. How you see that? What is the property of this image? And it's going to produce it created on the mirror. So the first of all, let me tell you how image going to be formed in physics. All of us, they understand. All of us, we understand wrongly. Actually, we know that in here we have image on the mirror, but in physics, let me check in here. Is it the same thing, the image that you have on the mirror? Actually, no. So look. This is the flat mirror. This is the flat mirror. And this is, for example, any object. For example, I'm going to put this person. Look. First of all, you should know every object, everything, every matter in this life, they are radiated some light outward. Some light of the object came out. Yani how, Mister? Yani for example, we understood first before like that. Only sun, they have ability to give us light. No, this is wrong. This is wrong. Yeah, this is right. The sun can give us light, but every object, even though this pen, now a lot of lights came out from this pen, but our eyes range cannot see the light that came out from the pen. Only our eyes, it can see the red one, not the other one, because a lot of lights came out. Only we can see the red one. So from now on, or even though this paper, a lot of lights came out, but actually our eyes cannot see. So from now on, understand every object, they have ability to emit light from it. Okay. So now in here, I only take one or two light because it's going to be complicated then. Okay. This light, it emits from this. Let me say this source came out from this source in that direction and hit this surface. After that, going to be reflected. You know this. When this light strike at this point, at this point, we can make another line, dot line behind the mirror like that. Okay. Then maybe another line in here. It came out from the source and hit this point of the surface. Again, behind the mirror, we have again the dot point to kind of stitch like that. So in here, look, there's two rays that came out from the source. The first of all, in that direction, I'm going to be reflected at this point. This is the point of hitting the surface, and this is the point of the second ray to hitting the surface. So you have first ray and second ray. So at the first ray, we can extend another dot line. At the second one, you can extend another dot line. We see that both of these dot lines, they are intersecting in this point. Both of them behind the mirror, they are intersecting in this point. So in this point, image going to be formed or going to be created. So now we understood something. Behind the mirror, the process is going to be happening behind the mirror. When the light it hit this mirror, and I know it's going to be reflected the light, but after that, behind it, there is a lot of process. At this point, the lights hit this mirror. At this point, the light hit this mirror. But at this point, we can extend. We can make it long. This line, dot line. Both of them, they are intersecting in this point. So at this point, there's image produced. In this point, image going to be produced. We know we can see the picture on the mirror. We know, yes, we can see our body again. But in physics, actually, behind the mirror, we have image. There's image going to be formed. So the image that's going to be formed in flat mirror is behind the mirror. Okay, I know, as I told you, we can, but let me repeat again for you. This is the first light came out from this source and it hit this surface and going to be reflected. This is the second light came out from this source and hit the surface and going to be reflected. Okay, but because this is the point of hitting the surface, at that point the light hit the surface. In here we can make a dot line, another line like that, another dot line like that. We see that both of them are both of them are intersecting in this point. If more than 2 or 3 lights are intersecting at the same point, so directly you can decide that at that point we have image. Clear? Good. So the first property, the image is virtual. Why virtual? Because located behind the mirror. Because as I told you, the type of the image in here virtual, because there is image, but behind the mirror. This is the image, but behind the mirror we have image. As I told you, don't get me wrong. I know we can see our picture on the mirror, but physically the process is going to happen behind the mirror. So this is called virtual image. The second property, the image is upright, but it's opposite left and right. You know what is the image of upright? It means this is the first picture of the person, and the person he can see his picture by the same direction without flipping, without flipping. This is the first picture, there's a second picture, they are same direction. Both of them, both of the direction of the person, both of them to the up. Right? Without being the picture flippings. But we have a problem in here. It's written left and right, but opposite left and right. If you notice that this is, according to me, this is the right side. This is the right side hand, but according to this picture, this has become left hand. This is right hand, this is left hand. Only the left become right and the right become left. Become changed only. This is the right side, but according to this person's image is going to be from on the mirror. According to this picture, this mirror, the hands become left. This is in here. It's written. This is right hand, but this become left hand of image. This is the right hand of the picture, but after when the image is going to be formed, the right become left. In here now it's left side. The third one, object distance is equal to image distance. Let me tell you here one thing. Object distance equal to image distance. This is the object. I put the object in front of this mirror. For example, the distance between the object to the mirror, for example, 6 meters or 6 centimeters. Okay. As I told you, where did the image located? Where did the image become produced at that point? Right. This is the image. This is the image. This is the same image of the picture that's located behind it. This is the image. This is the image of the object that become produced behind the mirror. So this is the object that we put in front of the mirror. The distance, it was 6 centimeters. This is the image picture that located behind the mirror. Again, the distance between this image to the mirror again 6 centimeters. So in flat mirror, this is the object I put in front of the mirror 6 centimeters. The image, as I told you, it was the image going to be created in that point, right? So the distance between the image to the mirror again 6 centimeters. So the distance between both of them are same. The object with the mirror and the image with the mirror, both of them, they have same distance. Okay. Look, object distance is equal to the image distance. Object height equal to the image height can never be displaced on the physical. Object height equal to image height. The size, let me make it nicer, the size of the object, the height is same like the object. Like the size, I mean, they have same size. It won't be like that. For example, the size of the object become less compared to the object, or the size of this image become larger. No, the size of the object and the size of the object, they have same height and same size. The last property said can never be displaced on the physical screen. Same thing as I told you. The picture can never be displaced on this mirror. It can be displaced behind the mirror. Good. So this is a really important property to know actually. The first, as I told, the image is virtual because we have image behind the mirror, and the image is upright. Both of the image are in the same direction, upright, without flipping one of them, and the image only left become right and right become left. The object distance equal to image distance. As I mentioned in here, this is the object distance, 6 centimeter, and this is the image distance, I guess 6 centimeters. So both of them, they have same distance. And object height equal to image height. This is the object size with image size. Both of them, they have same size. You can understand in here more actually. This is the pen. As I told you, every picture, every object, everything in physics, they are radiated sunlight. So in here we have two light. The first light from the head of this pen, light came out in that direction. If you notice that light, it came out in that direction and hit the surface, and again it reflected by the opposite direction like that. Can I write something? Wait a minute. Look, take a look. This is the direction of the light. It came out from the head of the pen like that. And after that, because the light, it hit this point of the surface, after that, the light, it reflected back by the opposite direction like that. Good. So in here, as I told you, on this point, the light, it hit the surface. The light, it struck at this point, right? So we can, as I told you, we can, behind the mirror, we can extend a dot line, and dot line. This is the dot line. The second light came out from the head of the pen in that direction, and it's going to be reflected. You know this after that. Again, where is the point that the light hit the surface? In that point. Again, at that point, we can make another dot line. We see that both of the line after when they are hitting the surface, both of them behind it, they are intersected in this point. They are intersected in this point. Yeah, and this is the first line that it hit the surface, and this is the second line that hit the surface. After that, behind it, as I told you, make another line like that, another line, extend these two lines, because both of the lines, they are intersecting in this point. Both of them, they are intersecting in this point. It means image going to be formed in this place. Image going to be formed in this place. So image going to form in this place. So let me repeat again the property. The first, we said the image size and the object size same. Of course, look, this is the size of the pen is the same like the image size. Both of them, they have same size, image size and object size. Both of them without the image, they've got same size without being like smaller or larger. So both of them, they have same size. The second one, the image distance, for example, this is 2 centimeter. It must be same like the object distance. The image distance and the object distance. So first we say the size are same. Their distance are same. Both of them, the direction of both of them is upright. Upright, without flipping, without being upside down. Look, the direction of the object is like that, and the direction of the object is still to the up, and both of direction is upright. Okay. What else? I think what is left? Yes, we said this image is virtual. Why? Again, this is the mirror surface, but there's an image become created behind the mirror. This is the image, and this is the mirror. Behind the mirror, we have the image. So this is called virtual. I think I'm done, but one thing is left to tell you, some names in here that we have. In this topic from now on, we have to name it like that. Look, this P is the distance between this object to the mirror surface. This is the surface. This is the distance between the object to the mirror surface. And this Q is a distance between the mirror and to the image. Distance between the mirror to the image, Q. And this P, the distance between the object to the mirror. Image to the mirror, object to the mirror. And this H dash is the height. This is the height of image. This is the height of the image. But that one, object, this is the height of the object H. And if you know, we have studied this in the previous section, this angle, the angle of incidence, and this angle of reflection. Good. I have wrote some questions for you, for my students, like we can solve together now. The type of the image become produced in flat mirror. Which one? Virtual because located behind the mirror. Real because located behind the mirror. Up, none. Of course, the correct answer A. Virtual located behind the mirror in flat mirror. Image size and object size, both of them say that we have in both of their size are same in flat mirror. Good. So we have studied the property of each one of them. And what is virtual image? Virtual image, an image that form at a point from which light appear to come but not. Look, take a look in here. Take a look in here. Virtual image, the definition, an image that forms at a point. Image, as I told you, image that going to form at which point? Behind the mirror. In here, at that point, we have forming image, creating image, producing image in this point. Behind the mirror, at that point, the image is going to be formed. So in here it said an image that forms at a point. At that point, the image is going to be formed. Which light rays appears to come, but do not actually come. The question said, we think that in here there is a light that passing to this point. That's why we have image. Actually, no, there is no light passing behind the mirror because all of them are reflecting. Look, when the light came out from this sword, it hit this surface. After that, it's going to be reflected. There is no light behind the mirror. Be careful. But that's why it's called virtual, because we are making line by ourselves. I'm going to make this dot line by ourselves, and I notice that both of the line are intersecting at that point. So in here we have image. In here become image producing. So in fact, there is no light that passing through the mirror. And be careful, all of them are going to be reflect. But we are doing this dot line by ourselves, and we notice that both of them are intersecting in this point. So in here we have image. So this is the meaning. An image that formed at a point, which light rays appear to come but actually not come. Good. This is the same thing that we said. Let me do it again for you. This is the object, the first property that we said, upright. Both of them, both of the object and the image, direction is upright, to the up, without flipping. Same thing, object distance and the image distance, same. One of the properties said the image located behind the mirror. This is the mirror. The image become located behind it. And the size of the pen, it's same like the size of the image, and so on. In here, look, we have, this is Q, and I told you all of them. Okay. One part it's left in here, mirror at an angle. What if we have more than one mirror? Let me see how image can produce. If we have more than one mirror, and how we can find, or let me ask you another question in general. If you have one mirror, if you have one mirror, how many image going to be formed? Because in here, if you notice that we have only one mirror, and only there is one picture become produced behind it. But no, in here is different. Since in here we have more than one mirror. This is the first mirror, this is the second mirror. Behind it, we see that we have three images going to be created. 1, 2, 3. So look. Look at here. In here, we have two mirrors, and two mirrors are putting over each other perpendicular. Yani this is the first mirror, flat mirror, and this is the second mirror. Both of them over each other. The angle between of them 90 degree. The angle between two of the mirror is putting like that, 90 degree. Is the first angle, is the second angle. The angle between of them 90 degree. At the same time, we are putting this O object. This O, it means object. We are putting this object in here, for example. And I told you, every object, they are radiated some light. Every object, they are radiated some light from the source. Some lights came out from the source. For example, the first light, it came out in that direction. In that direction, and then going to be reflected, right? Going to be reflected. At this point, because this is the heating of the surface, as I told you, extend this, make this long line. After that, we have another light came out in that direction, then going to be reflect in that direction, then in that direction. So in here again, this is the heating surface. We can make another line. Then another light came out in this direction. Maybe it reflect in that direction, and this is again another, and so on. It becomes so complicated to understand, like in which point that we have light. But this, for example, in here we have reflecting light, this point, at this point, and so on. We see that behind the mirror, there is a lot of image going to be created. Look, this is 1, and this is 2, this is 3. How do we know that actually? In here, only understand if we have two mirror are staying in front of up over each other, the angle is 90 degree. We have to use this rule. N is the number of the image, which is equal to 360 over theta minus 1. Theta is the angle between. Theta is the angle between the mirror. As I told you in here, the angle between the mirror is 90 degree. The angle between of them 90 degree. So equal 360, the angle between of them 90 degree, minus 1. So equal 360. This will be cancel. 36 left with 9 minus 1. 36 divided by 9 will be 4. So 4 minus 1 will be 3. So we see that in here, the answer 3. What's the meaning answer 3? It means in here, 3 image are formed. 3 image, look. 3 image are formed for an object in front of two perpendicular flat mirror. 3 image, look. 1, 2, 3. When the angle between of the 90 degree, there is 3 image behind the mirror. Again in here, same thing, Again, there is picture behind the mirror. But how many picture? 3. Why 3, mister? Because in here we have 2 mirror, and both of them is the angle between both of them is a 90 degree. This rule was important. Be careful. Now we are reaching in this section reviewing. Section review, chapter 5, section 2. Which of the following are examples of specular reflection, and which are examples of diffuse? Reflection, light from the surface of the lake calm day. Lake, it means ocean. The surface of the ocean, it's smooth. So this is specular. This is specular. Specular. The second one, reflection of a light from a plastic trash bag. Plastic, the trash, it's rough. So this is diffuse. Diffuse. And the reflection light from the lens, lens or mirror or the eyeglasses that you are wearing eyeglasses. There is a lens inside it, so the lens still is smooth. So because smooth, يعني specular. 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 The last one, reflection light from the carpet. Carpet it means in Kurdish يعني فرج مافور. So carpet surface رف زبرة. So the reflection of light, of course, diffuse. Diffuse. Okay. Done. Question 1. Question 2. Question 2. Question 2. Question 2. Suppose you are holding a flat mirror and standing in the center of the. Okay. And here actually have make a picture. Here we have to make a picture. In here, for example, you have this clock. This is 12. We know this is the time of the clock. We have to know this. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the question said, you are holding a flat mirror. If you are holding and standing at the center of the clock, face built into the floor. Someone standing at 12 o'clock. At 12 o'clock, shines a beam of light toward you, and you want to use the mirror to reflect a beam. It means some of the persons are standing in the center in here. For example, suppose you are holding a flat mirror and standing at the center of the clock. For example, I'm holding this flat mirror. Okay, this is me. I'm holding this flat mirror. And someone standing at 12 o'clock, and someone he's standing here at 12 o'clock. Yeah. Someone standing at 12 o'clock shines a beam of light toward you. He wants to give me some light toward me that direction. And you want to use the mirror, and I have to use the mirror to reflect the beam, the beam toward to this 5 o'clock. What should be the angle of the incidence? First of all, we should know actually. This person, he is standing here, and okay, so the angle between each of the distance between 12 the angle between each one of them is 30 degree. In here 30 degree, in here 30 degree, in here 30 degree, 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 30 degree. When this person he's staying at the 12 o'clock, he want to give me some of the light in that direction toward me, and one of the person he's standing at the center of this o'clock, and he is holding this mirror, and when someone's he or she give me this light, I have to turn the direction of the mirror like that to direct it toward the 5 a.m. I have to make it like this direction to give this 5 o'clock. I have to change the directions when I will receive this light. I have to transfer this light to the 5 o'clock. Okay. When this light it came in that direction, first of all we have to count it now. And here this is 30. 30 with 30, 60. 60 with 30, 90. 90 with 30, 120. 120 with 30 will be 150, right? The angle in here that we have is 150. So this is 150 because the distance between each of them 30, yeah, I mean the angle between each of them 30, the angle, and 2 plus all of them become 150. So students in here, look, as I told you, one of the person, he's standing at 12 o'clock, and there's another person, he's standing at the middle of this o'clock. He's holding this mirror. The first person, when he's standing or standing on 12 a.m., he's giving some of the light. Imagine this object, some of lights came up from this object in that direction. This person is receiving this light, but he's holding this mirror. While he's holding this mirror, he has to change the direction of the mirror. He has to fix the direction of the mirror, because we need to direct this light to the 5 o'clock in here. We have to bring or transfer the light in that direction to 5 o'clock. As we know that the angle of in here from the 12 till 5, the angle of this hole is 150. But we see that in here we have a dot line. If you remember, we studied that we have this dot line direction like that. The question said find the incidence angle. If the whole angle is 150, if the whole angle is 150, how we can find the incidence angle? We have divided by 2. Divided by 2 will be 75. So according to the law of reflection, this is the incidence angle. This incidence angle 75, and this is the reflection angle still 75. Because this is the direction of incoming light, and this is the direction of the reflecting light. They are reflected by the same angle, 75, 75. Question 3. Question 3 is not important. Question 4. Good question. The photograph in figure 5.5 shows a multiple image that were created by multiple reflection between two flat mirrors. What conclusion can you make about the relative orientation of the mirror? Let me change the idea of this question, or let me tell you. Wait a minute. The question said if when that we can make a multiple reflection, or when we can shows multiple image. When do we have multiple image or multiple reflection? When we have two mirror and both of them are putting in front of each other. Do you remember the previous page as we studied? If you have two mirror and both of them they are over each other, the angle between of them 90 degree, only there were 3 images become produced by using the rule. But in here the angle between of them zero. You know why? Because these two mirrors are putting parallel to each other. Both of them they are parallel, so the angle between of them 0. Because the angle between of them 0, let me use the rule n, which is equal to 360 over theta minus 1. 360 over the angle is 0 minus 1. In here we have number divided by 0. So number divided by 0 we cannot solve it. Number divided by 0 it means infinity. So it means if we put the object in here, for example, become multiple reflection. So when we have two mirror staying in front of the object, putting in front of each other, because the angle between of them 0, at the end the n number of the image become infinity. There is a lot of image, we cannot count it. That's why in here it is written multiple reflection. Yes, you have multiple reflection. We cannot even count because the direction of putting mirror is parallel. So shows multiple image. Yes, you have multiple image or we have infinite image were created by multiple reflection between two flat mirror. What conclusion? The answer is the light must be reflected from one mirror to another in order to form image. Of course, you have to reflect the mirror to reflect picture to form image. Therefore, the mirror must be exactly parallel to each other. The answer, we have to put both of them parallel to each other to create multiple image. So the answer is the light must be reflected. The light must be reflected from one mirror to other. This is the light. This is the mirror, right? The light are reflecting in this mirror, then to the second mirror, to maybe again to the second, like that. We have multiple reflection. Therefore, the mirror must be exactly parallel to each other. mirror must be exactly parallel to each other. Then we can get multiple image. So students, question 5 and 6, you can solve it and not that much important actually. So students, we have done section 2 chapter 5. Inshallah, for the next video we are going to start explaining chapter 5 section 3. Thank you for all.